Okay, in this example, we're going to look at still multiplying two rational expressions, but if you notice, the second one doesn't look like it's a fraction. Keep in mind, to make any whole number a fraction, you would put it over 1. So we now took our little polynomial there and made it look more like a rational expression that we've been studying. So keep in mind, when you're multiplying rational expressions, we want to factor first. So I'm going to start with the first fraction here, x plus 3 I can't do anything with, but x to the 4th minus 81, that looks like a difference of 2 squares. So I'm going to factor that. And then if you guys notice right here, x squared minus 9, that's another difference of 2 squares. So we can actually break that one down even more. Okay, and then let's look at the second fraction. It looks like on the numerator, they have a GCF. And remember, GCF is the number one way that we always look for factoring. So if I factor out that x, I'm left with this trinomial. Now that trinomial is also something that can factor because I know 4 times 3 is, 4 and 3 make 12, but to get negative 12 and a positive 1, I could do x plus 4 and x minus 3. So you can rewrite that. Now looking at our domain, so in my domain here, I just really can't have x equaling 3 or negative 3. And we are only worrying about real values. So I know x squared plus 9, that's going to make an imaginary value. We're looking at just real values. So now we're ready to start dividing out common terms. So x plus 3 over x plus 3. We got an x minus 3 and an x minus 3. And that looks like that's about it. So if I put what's left in the numerator, I have an x and an x plus 4. In the denominator, I have x squared plus 9. And I say for x not equal to 3 or negative 3. And that would be the solution.